Okay, so let's talk about this. This is some flawed logic. And the understanding of the flawed logic is simply that the sun behaves a certain way when it's orbiting over a flat plane versus if it's orbiting around a spherical object, right? So the sun has to behave a certain way on a flat Earth, and then it has to behave a certain way on a sphere. We don't have to measure things on the ground to be able to determine the shape of the Earth. We can use things like sundials and compasses and all these other things to help determine the shape of the Earth. Now, any one of those things, any one of the things that I've shown, demonstrated, will show that the Earth is a sphere and is not a flat Earth. But I compound that proof with other things. So that's why the sphere is pretty much ironclad, because everything demonstrated demonstrates successfully on a sphere, and nothing demonstrated demonstrates successfully on a flat Earth. So what we have here, and we're going to demonstrate this, the reason why the sun can definitely determine the shape of the Earth is through this simulation. So again, we have to use visual aids and simulations because we can't just fly out into space and look at things. So we have to do things in simulations or in modeling because we can't see the entire planet from the ground. So anybody out there that's going to complain about this being a computer simulation, you try to explain how we're going to determine the entire planet without using a simulation. So here it is right here. So we are going to demonstrate, this is just on this latitude position. So I got that positioning from looking at suncount.org and seeing the sun's path and how it hits South America. So we're just trying to get it as close to that position as possible on this flat plane. But what I did is I ended up making a sun follow an orbital path around the flat Earth with a constant elevation angle on a 24-hour day, and how it actually is in observed reality arcing across the sky. So let's take a look at that. So we're gonna throw these two suns, right? We got one orbiting a constant elevation at a constant latitude position in a 24-hour period, and then we have one that is going to a maximum elevation angle of 43 degrees at solar noon. So let's just kind of look at this from the side, and we're just going to look at this from different directions here. So here is the one that is doing how we observe it in reality, which is the one that's going up and down, and it does the sunsets and does everything as we observe. And the other one is rolling around the flat plane at a constant elevation angle. So let's jump into our observation here from the ground level. So again, this is the sun following the laws of perspective, getting smaller, and as it gets closer to us, it's going to get bigger. And here's that other sun, boom, solar noon, and the other sun's going to sunset. And then you have this object here that's, again, getting smaller and bigger, as it goes further and closer away from us. So the question is, and what flat earthers won't answer, is which one matches observed reality more? The sun that is rotating at a constant elevation angle in a 24-hour day, or the sun that has an angular orbital path like so. So now the one thing that we can't determine is distance, right? So that's what the amazing thing about this is we don't need to determine the distance of the sun from the Earth to verify the shape of the Earth, because in this scenario, the sun is hitting the flat Earth, right? So we can make it maintain a constant 43 degrees elevation at solar noon, and we can make it not hit the Earth. So we can fix some problems here. But the one thing that's not going to work is the flat Earth ideology of the sun being local. Because as soon as I make this orbital path actually go outside of the flat Earth, then that no longer allows the sun to be local, right? It's outside of the dome, so to speak, or outside the Earth. So right now, it's inside the Earth. And this is how I've measured the sun's position in the sky when I do these experiments and measurements outside. This is what the sun is actually doing. If you watch my Fusion 360 videos, this is exactly what the sun is doing. So we can make its orbital path bigger, but again, it breaks one of the rules of flat Earth, meaning the sun is local. So, and we can make it do a sunset, but another problem is as soon as you introduce a second individual or a second observation point, this fails completely in both regards, right? So I can't have the sun doing this at my position and it also doing the exact same thing from South America or Africa or so on and so forth. So quite easily, the sun is able to help us determine the shape of the Earth. And very quickly, we know that the sun can't be flat because of the orbital path of the sun as we observe it on our beautiful round Earth. I hope this helps. You guys take care. Have a great day.